Let's do some math. In this video, I want to talk to you about factoring, and I want to do just a quick overview. Obviously, this is not a ton of examples. If you want more practice, I've got a couple videos specifically on these, and also there's tons of practice on IXL, Khan Academy, and if you just Google, you'll find countless worksheets on this. So let's start with factoring by GCF. The first thing we want to do when we're factoring is always try to find a greatest common factor. What can we take out of everything? So I'm going to show you what that looks like. The first one we have here has two terms. This is a binomial. It has two terms. I can take out a 3, and I can also take out an x. Now, since they both have an x with an exponent, I'm going to take as many x's out as I can, and I can take out 2, because if I took out more than 2, then I wouldn't have enough in this guy. So that ends up being x squared minus 3. Look all right? The next one, what we want to do is same thing, except this time we have 3 terms. 1, 2, 3. Looking at the numbers first, and then the x's, then the y's. The number that jumps out is a 7. A 7 can be taken out of each one, right? 7, 7, and 7. They can all be divided by 7. They can also all be divided by x. Actually, they can't because there's no x here. They can't all be divided by y because there's no y here, which means the only thing we can do is take out a 7. And if we simplify each of those, we end up with 49 divided by 7 is 7xy plus 4x minus 2y. And all we did was took out a 7. Let's look at a third example. This one has a little bit more for us to take out, number 3. But when we look at this one, we're going to look at the numbers. Look at the numbers, and then the x's, and then the y's. So the numbers, what can I divide 18 by and also divide negative 12 by? Well, the answer is going to be 6, obviously, right? I can take a 6 out of each of them. And what can I divide both of them by when I'm talking about the x's? Well, I can take out x's, and I can take out 3 out of this one, and I can take out 3 out of this one. If I try to take out more than 3, then I couldn't take more than 3 out of the first one. When I look at y's, how many y's can I take out of each? And the answer is 2. 2 is the most I can take out of this one. So that's the one I'm going to take out of both of them. Now, if I take that out, that means we're going to pull that onto the front. 6x to the third, y squared. And then in parentheses, we're going to end up with 3y to the third minus 2x, close parentheses. And that's it. That's all there is to it on this factoring by greatest common factor. And a lot of you do really well at that. But then your algebra teacher hits you with factoring quadratic expressions that are trinomials. We spend a lot of time factoring trinomials. That's because we have 1, 2, and 3 terms. And I want you to notice that there's nothing we can take out of that. In fact, all 6 of these on this page, all 6 of these don't have a greatest common factor. If they did, we'd go ahead and do that first. But since they don't, what we're going to do is we're going to start by saying, okay, we're going to have to come up with a new technique using trinomials. And we do that first recognizing ax squared plus bx plus c. We have an a b, and a c. So if I looked at this first one, I'd have an a equals 1, a b equals negative 3, and a c equals positive 2. And then what we want to do is we want to figure out what are 2 things that multiply to give me what a times c gives me. Now, a times c is 1 times 2 in this problem, so that's 2. And it has to add to give me what the b equals. What are 2 numbers that multiply to 2 and add to negative 3? And so those 2 numbers would be negative 1 and negative 2. If we were to try to multiply those together, they'd give us that. But if we were to add them together, they would give us that. So we're going to go ahead and use that and split this up. So I'm showing you way too much work here. I normally do a lot of this in my head, so I didn't give you a lot of space to work with. So I'm going to go ahead and I'm going to split the middle term. So I have minus 3. That's kind of like saying minus 2x and also minus 1 more x. Do you see how that middle term, which was just minus 3x, is now these two? And can you tell that those are the same? That means the same thing. So what we're going to do from there is then we're going to use our technique of factoring, just like we did on the last section. And I'm going to do it like this. I'm going to look at the first two, and I'm going to look at the last two. And I'm going to find the GCF of the first two terms and the GCF of the second two terms. Now, this method is splitting the middle term and factoring by grouping. This is more complicated than it has to be. I say that because on this problem, it's more complicated. I like to use this method because it's going to work for 4, 5, and 6 really well. So what can I take out of the first two? And the answer is going to be an x, and I'll leave x minus 2 on the inside. Now, the second two, what can I take out of there? Well, we have a negative 1x in front, so I'm going to take out the negative 1. And if I do that, I end up with x minus 2, because if I take out a negative 1 out of the positive 2, it becomes a negative. Now, I've got this expression. I have now factored this, and this is 100% accurate. And I want you to notice we have those, but we also have, let's switch colors. We also have the stuff we took out. So we have the stuff on the inside, and we have the stuff on the outside. And the stuff on the inside is x minus 2. That's one of our two factors. And the stuff on the outside is x minus 1, and that's our other factor. Now, we can simplify it, and so I'm going to show you how we simplify that just a little bit here when we do the second one. But I like using that method because it's going to work well for 4, 5, and 6. If we do the second one, I want to say, what are two numbers that multiply to AC equals 6 and B equals 5, but the 6 is a negative. So I need two numbers that multiply to a negative 6 and add to a positive 5. And so that means the two numbers are going to be what? They have to add to a positive 5 but multiply to a negative 6. So that's going to be positive 6 minus 1, so 6x minus 1x. From here, we can go ahead and factor the first two and factor the last two, just like we did on the last problem. And what we're going to end up with, if we follow that pattern, is just going to be x plus 6 and x minus 1. And you can see how that's very similar to the last one. But I want you to draw your attention to the fact that minus 6 and 1, or positive 6 and minus 1, were the two numbers that we got right from the beginning. So we can kind of skip this middle step as long as the a, the number in the front, is just a 1. If there's no number in front, that's not a problem. So when we look at number 3, this time the a is 2. So AC is negative 6 and B is positive 5. And so you go, oh, this is the same number, so we're going to use the same ones. So we're going to say, okay, great. I know exactly what I'm going to do. I'm going to do negative or positive 6x minus 1x. And we go, oh, great. This is going to work out perfectly. Except the catch is it's not going to work out the same way it did, because in the last problem, there wasn't a 2 in the front. So we had a different factor once we did this next step. The reason I like to use this method the whole time is because when we do this next step, we make less mistakes. I'm going to go ahead and take out greatest common factor. What can come out of both of those? Not just the x, but a 2x. On the inside, it would be an x plus 3. I can take a minus 1 out of the second one, and I get x plus 3. Notice again that we have the x plus 3 and x plus 3. Those match up, and I've got this other part on the outside. So we can then use those to write x plus 3 and 2x minus 1. And so when we have this number in front, this a not equal to 1, there's a little bit of an advantage in using this split and grouping method. I'm going to jump to number 6. When I look at number 6, I get A and C are 60 and B is negative 19. So what are two numbers that multiply to 60 and add to negative 19? Giveaway here, since they multiply to a negative, multiply to a positive, they both have to be negative or both positive. So this is going to be two negative numbers. So we could say, ooh, maybe it's going to be negative 20 and negative 3. Nope, that doesn't work. What are other numbers that multiply to 60? Negative 18 and I don't know. That's not going to work well for me, is it? I'm trying to come up with numbers that multiply to 60. So if you have this feeling that like only great mathematicians can solve these problems, that's not it at all. It's just that you need a strategy that's going to work for you. So what I like to do is I like to start from the top. So I'm going to go ahead and divide because I'm going to find the two numbers that make 60. I know they're both negative, so I'm going to try negative 1 and negative 60. Does that add to negative 19? Nope. Negative 2 and negative 30. Nope. Negative 3 and negative 20. Negative 4 and negative 15. You notice I just counted 1, 2, 3, 4. That's all it took. And guess what? That one works. That gives me negative 19. So even as these numbers get larger, it can be very overwhelming to go, oh, I can't come up with a matching pair. If you just start at the beginning and work your way up, just count. That's all it takes. And so we're going to split the middle term and have 10x squared and plus 6. We didn't change those. But the middle part switches to minus 4x minus 15x, right? Because we have that, splits into those two. Next, we're going to go ahead and look at the first two, and we're going to look at the last two. And we're going to factor. What can I take out of the first two? I can take 2x, and on the inside, I'd end up with 5x minus 2. This one, I can take out a negative 3, and that's going to give me, well, 5x minus 2 again. And so my final answer ends up being 5x minus 2 and 2x minus 3. I'm going to leave the last two for you as practice just for yourself. Thanks, guys.